welcome back to our channel. In this session, we'll be talking about container registries, an important aspect of modern software development. If this is new to you, don't worry. We'll cover everything you need to know, step by step. By the end of this session, you'll understand what container registries are, how they work, and why they're crucial for successful containerization. So let's dive into it together. So what exactly is a container registry? It is a place where you can store your Docker images, something like a virtual warehouse for all your containers. With a container registry, you can easily share, reuse, and distribute container images, which saves time and reduces errors. It is something like a centralized platform used to manage and distribute container images. It can be accessed from anywhere in the world. The most popular container registry is Docker Hub. It's a popular public cloud-based registry where you can find thousands of pre-built images that are ready for use. For more on this, you can check out our video on Docker third-party images in the link below. Now let's talk about some of the key features of Docker Hub that makes it so special and popular choice for developers. Docker Hub provides pre-built images for various software applications, including official images for popular software such as Nginx, Apache, MongoDB, Node.js, and so on. These official images are maintained by Docker and the respective upstream software vendors, ensuring that they're reliable, up-to-date, and secure. Using these official images saves time and effort that would have been spent building and configuring custom images. Docker Hub provides a vast collection of public repositories that contain pre-built images for different programming languages, frameworks, and applications. This library is a valuable resource for developers who can easily find and use the required images, thus saving time and effort during the development process. If you need to store sensitive or private images, Docker Hub provides a way to do this. It allows you to create private repositories where you can securely manage your Docker images with control access. This is important if you need to keep your confidential data and intellectual property safe. With a private registry, you can control who can view, download, or modify your images. Amazon ECR is another option or alternative for private Docker image repositories. It provides secure storage for your images and supports Docker image formats. You can easily upload, manage, and deploy your images with these services without having to worry about the technical aspects. These services can also integrate with popular container orchestration tools such as Kubernetes or Docker Swarm, making it easy to deploy your images to production environments. This is a useful feature that builds and updates images automatically whenever changes are made or triggered to the source code repository. This feature simplifies the continuous integration and delivery, known as CI/CD pipeline, making sure that the most up-to-date version of the image is always ready for deployment. Docker Hub helps teams work together by providing collaboration tools such as organizations and teams. These features allow developers to work seamlessly, share repositories, and manage access permissions effectively. This creates a collaborative and productive environments for development. It also has a feature for security scanning that we mentioned earlier that automatically checks Docker images for known vulnerabilities and issues. It helps developers detect and address security vulnerabilities early on in the development cycle. This reduces the risk of security breaches and ensures the safety of deployed applications. And lastly, developers can automate certain actions in external systems with Docker Hub webhook support. For instance, a new image push or the completion of a build can trigger automated actions like notifying a CI/CD pipeline or triggering a deployment process. This integration capability increases workflow efficiency and automation. Docker Hub is a popular platform for container registries. However, there are other options available that offer unique features and functionalities to meet different container registry needs. It is important to explore these alternatives to make an informed decision when selecting a container registry for your Docker images. In this section, we'll discuss some of the most popular Docker Hub alternatives, highlighting their key features and benefits to help you choose the right one for your requirements. Amazon Elastic Container Registry, or ECR. ECR is a fully managed container registry provided by AWS, designed to store, manage, and deploy Docker images. It integrates tightly with other AWS services, making it ideal for organizations already invested in the AWS ecosystem. How do we actually use this? Users can pull, push, and manage Docker images using the AWS CLI, SDKs, or through the popular AWS Management Console. ECR supports both public and private repositories with fine-grained access controls. Why would we use ECR? ECR offers seamless integration with AWS services such as AWS ECS or EKS, as well as AWS Code Pipeline and AWS Code Build, simplifying the CI/CD pipeline setup for containerized applications. Its scalability and reliability make it a solid choice for cloud-native applications. ECR integrates with AWS Identity and Access Management, also known as IAM, AWS CloudFormation for infrastructure as code, as well as AWS Code Pipeline and other third-party CI/CD tools such as Jenkins, GitHub Actions, GitLab, and so on. Google Container Registry, or known as GCR. Google Container Registry is a managed Docker container registry provided by Google Cloud Platform, or GCP, allowing users to store, manage, and deploy container images securely. Users can also push, pull, and manage containers images using the gcloud command line tool, Cloud Console, or Google Cloud SDK. As we can see, a lot of similarities between the two cloud providers. GCR integrates seamlessly as well with other GCP services, offering a unified platform for containerized application development. The reason why we use GCR is because it provides high availability, scalability, and low latency access to container images worldwide, leveraging Google's robust infrastructure. It is an excellent choice for organizations who are already utilizing GCP or seeking a cloud-native container registry solution. GCR integrates with Google Kubernetes Engine, also known as GKE, Cloud Build, Cloud Functions, Cloud Run, and other GCP services, enabling end-to-end containerized application development and deployment workflows. A last example we'll give on GitHub Container Registry, which is a fully integrated container registry offered by GitHub itself. It is allowing developers to store, manage, and share Docker container images directly within their GitHub repository, which makes it even more convenient. Users can push, pull, and manage container images using the standard Docker CLI or GitHub Actions. GitHub Container Registry leverages the familiar GitHub interface, making it easy for developers to work with container images alongside their source code. GitHub Container Registry offers a seamless integration with GitHub repositories and workflows, streamlining the development and deployment process for containerized applications. It is an excellent choice for organizations heavily invested in GitHub for version control and collaboration. GitHub Registry integrates natively with GitHub Actions, enabling automated image builds and deployments directly from GitHub repositories. It also supports integration with other CI/CD tools, such as Jenkins or GitLab or Travis CI, extending its flexibility and compatibility with existing workflows. These alternatives can be evaluated based on the organization's requirements, compliance needs, and preferred cloud platform to optimize containerization strategies and DevOps workflows. By exploring these options, developers and organizations can find a solution that suits them best. Let's discuss the best practices for tagging Docker images. When tagging your images, it's important to use descriptive and meaningful tags that reflect the content of the image. This helps in managing and tracking your images over time, and also ensures clear and consistent deployment of containers. Here are some tips for tagging your images properly. First example, we'll talk about semantic versioning with clear versioning schemes. Semantic versioning is a standard way of assigning version numbers to software releases. It follows the formats of major, minor, patch. Adhering to semantic versioning helps convey the significance of changes and ensures compatibility. For more information, please visit this website. Here are a few examples demonstrating semantic versioning using the major version, minor version, and the patch formats. Example number 1, we have version 2.1.0. Major version, or number 2, represents a significant update or changes that may introduce breaking changes to your environment. Minor version, or number 1, represents new features or enhancements added without breaking existing functionality. And the last one, patch version, or number 0, represents bug fixes or minor updates to maintain stability and compatibility. Another example, we could use a version 1.2.3-beta.2 to make it a little bit more complex. Major version, or number 1, will show us the initial release or significant updates in this case. Minor version, or number 2, it represents incremental updates or new features added without breaking changes. And the last one, the patch version, or number 3, refers to bug fixes or minor updates maintaining stability. Pre-release or pre-release identifier, such as stated in here, beta.2, indicates that the version is in the beta stage of development, which means it's still undergoing testing before the final stable release. The next on our list is tagging strategies, ensuring the latest version is clearly identified. What does this mean? Well, in the best practices, we would always tag the latest version of the container image to provide a clear reference for users in automated processes. Using the latest tag can simplify deployments but ensure it's consistently updated to avoid any confusions. An example command for this would be docker build -t, the name of your username used in a Docker Hub, and the actual name of the application, which in this case can be app-name, with specific tag of the latest, indicating the latest version of this app. When labeling Docker images, it is advisable to use descriptive tags that convey meaningful information about the image contents, such as application version, any dependencies or configuration details. Consistency in labeling conventions across projects improves clarity and facilitates maintenance also for other people. Here's an example of how you can create a descriptive Docker image tag using the docker build command with appropriate labeling conventions. Be docker build -t, the name of your application, and then we'll use V for version 1.2.3. In this case, my app will represent the name of the application or the projects you're working on. It provides the context about the content of the image. Version 1.2.3 denotes the version of the application being packaged into the image. This is also following what we mentioned before, the semantic versioning, indicating major, minor, and patch versions. When you use a descriptive tag like my app version 1.2.3, it really helps to communicate the important information about the contents of the image, such as the name of the application and its version. This allows you to better manage and identify images, especially when certain or additional complexity is added to it later on, and where there are multiple versions or variations to also be dealing with and consider. The next one we will be talking about is regular retagging, or ensuring images stay relevant and secure. It is important to regularly review and update image tags to make sure they reflect any changes, fixes, or updates. This helps maintain consistency and prevents outdated or vulnerable images from being used. Automated pipelines can make things easier for us by automatically tagging and pushing updated images whenever the new code changes or releases are being made. Once an image has been pushed to the registry, you can retag it by following a simple process. So the first command we would run is docker pull my app and then specifying the version, let's say 1.2.0, which will pull the image from the registry with that specific version. We can then retag the image with a new version, and we'll run the command docker tag my app version 1.2.0, which is the existing one, the one we just pulled down from the registry. And then we'll specify my app with a new version tag, which will be in this case v1.2.0. Once we're done with that, we'll push the retag image back to our registry. So the command for that will be docker push my app, and then we'll specify the latest version or the new version, which will be v1.2.1. The next in line is environment and architecture specific tags. When creating and tagging Docker images, it is important to use specific tags that match the environments and architecture you're deploying to. This ensures that your images are compatible and resources are used efficiently. You can use tags such as production, staging, or dev to differentiate between environments, and include architecture-specific tags such as AMD 64 or ARM 64 for multi-platform support. Here's an example demonstrating how to use environment-specific or architecture-specific tags when building and tagging Docker images. So for production environment on AMD 64 architecture, we can run a command such as docker build -t, the name of your app, and then specifying the version, or let's say the environment's production-AMD 64. In this case, docker build command is used to build this Docker images for different environments. Let's say we could use also example for staging and development, or different architectures, maybe something like ARM 64 as well. Tags are structured to indicate the environments, production, staging, dev, and architecture, AMD 64 or ARM 64 for each image. And the last example would be leveraging automation or streamlining builds and tagging processes. To make things easier for us, there are certain tools that can help us create, tag, and distribute images. And these tools like Docker Hub, automated builds, or GitHub Actions, or even Jenkins pipelines can automatically build, test, and tag images based on predefined rules and triggers. By using these tools, you can maintain consistent and manageable container images throughout their lifecycle. To ensure improved efficiency, reliability, and maintainability in containerized environments, you can follow best practices such as semantic versioning and automated tagging. Here's an example of how to use GitHub Actions to automate image builds and tagging based on commits. So in the following example, we'll see a GitHub workflow for our GitHub Actions that we'll use to basically build a Docker image and push it to Docker Hub. In this GitHub Actions workflow, we've seen that the workflow triggers on pushes to the main branch. You can adjust the branch name as needed for your personal needs and requirements for this demo. The build and push job runs on a Ubuntu environment as specified in the workflow itself. The workflow checks out the repository code. The Docker Registry login step uses Docker credentials stored as GitHub secrets. So we've got, in this example, Docker username and Docker password. The Docker build commands build the Docker image with the unique commit hash, which is stated as github.sha as the tag. The Docker tag command tags the image with both the commit hash and the latest tag. We then have the Docker push command that pushes the built image to the Docker registry. This workflow automates the image build and tagging process whenever there's a push to the specific branch, let's say, ensuring consistency and reducing manual intervention. You can adjust the workflow as needed to really fit your specific requirements and Docker image naming conventions. If you're interested in using Docker Hub, the first step is to create a free account on their website. Once you're signed up, you can use the Docker command line tool to push your local images to Docker Hub. This can be done by first logging into Docker Hub with the following command, docker login. Once you're done with the setup, we'll go through the process of building a container image, inspecting its layers and pushing it to a container registry with Docker. So this is an example of our Docker file. So we'll be using a base image, Ubuntu latest, We'll set some environment variables such as app version 1.00 and also an app environment production. We will then run a couple of commands to install required dependencies. We'll copy the application files to .app directory. We'll set the working directory to the app directory. And at the same time, if needed, you could expose the port on 8080. And the last command we'll run is the .app.sh to actually execute the application. Assuming that the Docker file is in the same directory as your application files, you can build the Docker image using the docker build command, which we've seen before, such as docker build -t, and then specifying the name that you want to give to that specific image, and then you can also tag it as latest. Once that's completed, and after you successfully build your first image, you can inspect the created image by using the following Docker commands, such as docker image ls to list all your existing images on the local machine. You can also run docker history and then specify the name of the newly created image to show the history of image layers, including commands run in each layer during the build process, which can be quite handy. Another really good command to know is docker inspect and then the name of your image, which will allow you to view the layers of an image, which you could also find and pretty handy during the troubleshooting. And lastly, if you would like to remove that specific image, you can just run docker image remove and specify the name of the image. Assuming you have access and that you've successfully previously logged into your container registry on the Docker Hub, you can push the built image to the registry using the docker push command. So that will be docker push and then specify your Docker username, the name of the app, and the version you've given it to. This command will then push the image to the specified registry, making it accessible for deployment on other systems. And these steps will help you create, inspect, and upload container images. So this will allow you to deploy your applications consistently across different environments and infrastructure setup. And you can also make changes to your Docker file and commands to suit the specific needs of your application, deployment environments, or troubleshooting purposes. We would like to express our gratitude for taking the time to watch our guide on container registries. We hope that our video was informative and valuable to you. If you have any unresolved queries or would like us to cover specific topics related to Docker or anything else in the future, please do not hesitate to share your suggestions with us in the comments section below. We value your feedback and we're always eager to hear from you. We're also excited to announce that in our next video, we'll be covering Docker Compose, and we encourage you to stay tuned for more updates. Thank you for watching, and we really appreciate your support. Don't forget to hit that like button and subscribe to our channel to stay updated on our latest content. See you soon.